thank you very much for joining us here today. This is the European Heat Pump Association webinar on planning support for green buildings and cities. We've got three panelists who are going to share their thoughts with us today. From my point of view as an introduction, it's worth saying that, whilst COVID remains on the front pages of our newspapers justifiably, the climate crisis continues unabated, even if it's not on the front pages. It's worth remembering that Siberia is literally on fire at the moment. So these are not theoretical things we're discussing. Now, the old adage is, how do you make sure that a crisis doesn't go to waste? Cities are trying to make, obviously, the most of their COVID crisis. They're up to their necks in things that they have to do. But from my point of view, systemically, right now in Europe, very little has changed. Flying is down and cycling has had a boost, but the systemic issues that cities face in trying to green themselves in terms of trying to green their buildings remain absolutely the same, whether those are fossil fuel subsidies, tax policies, agricultural policies, just about everything. Those systemic issues that make decarbonization such a challenge are still there. So hopefully we'll be able to face some of those issues today from our three panelists. My name is Adrian Hiel. I work for Energy Cities, which is a network of about 1,000 cities across Europe striving to be much more sustainable, using local resources first and renewable energy. We work in two ways primarily. One, we share information within our network. So if Strasbourg has a great project on how to develop geothermal, they can share that information with other network cities. The other way we work is to lobby the European institutions to try and make those systemic policy changes we need to allow cities to become more sustainable. So that means funding, of course, but it also means ensuring that cities have a seat at the table when we're discussing things like the Green Deal, the recovery package that we've all waited for after the MFF discussions finished yesterday morning. So green buildings, which is what we're talking about here today, are a massive part of our energy consumption. They represent anywhere from 35 to 40% of Europe's energy demand. And so if we're going to decarbonize, it absolutely has to be one of our primary functions. It's definitely one of the key challenges of the Green Deal. So a lot of debate goes into what makes a green building. You could build a new passive house out of 4 meters of concrete, so your upfront emissions are enormous, but your operating emissions are nil. Vice versa, is it better to knock down a leaky old building and build a new one, or is it better to try and retrofit that leaky building? It seems like a simple thing, a green building, but it's really far from simple. There's a lot of things that go into it. For cities, and specifically for politicians, one of the biggest issues is that they need to consider the people who live in those buildings first and foremost, because those people are voters. And so there's a very clear limit as to how far politicians can push people and citizens to upgrade their buildings. So there's a mix of incentives to improve buildings and lower the carbon emissions. And then there's also mandatory changes that maybe need to take place and force people to do that. But that becomes quickly very, very politically unpopular. So there's also the policy landscape, of course, which has a number of conflicting objectives and can throw up unexpected roadblocks. Now, we're not going to solve all of those challenges today, but I do think we're going to get some insights into the challenges that cities are facing in terms of decarbonizing their buildings. So without further ado, I would like to introduce our three speakers for today. We'll start with Dr. Martin Jakob, who's the co-founder and executive partner of TEP Energy. That was founded as a spin-off of the company ETH Zurich in 2008. So Martin and his team provide research and advice with a focus on energy modeling and empirical studies, addressing technological, economic, and policy aspects related to energy. He's responsible for conceiving and further developing energy models, coordinating and conducting empirical research, and client-specific advice on implementation of projects. So his key competencies and experience include building physics, energy technology, economic and political policy analysis, energy efficiency, renewable energy use, energy demand, and energy modeling. Like I said,
Oh,
there's a lot that goes into a green building, huh? There's a lot of different elements here. Martin holds a Diploma of Physical Engineering and Masters of Science from the Swiss Federal Institute of Technology in Lausanne, with a focus on building physics, and a PhD from ETH Zurich, where he promoted in 2007 the field of energy economics. Before that, he was a senior researcher at the Center for Energy Policy and Economics of ETH Zurich and a responsible researcher at the Paul Scherrer Institute in Villingen. That's Martin's introduction. I'm going to go through our next two panelists, Chris and Steffen, as well, and then we're going to hand it over for a few open questions before we get into some interesting case studies. So Chris Caerts is a research activity leader at VITO NV. He's leading the research activities that focus on the characterization and modeling of building and district level flexibility, which is a really key thing, that district level approach. We should see more of that in the renovation wave when it comes out in October. So that's with respect to energy consumption and how such flexibility can be used to support the needed energy transition, and more specifically, the decarbonization of our buildings and cities. So an important aspect of this deals with how buildings can interact with each other to create energy communities, and how such buildings and communities interact with the grid and market stakeholders. In relation to this, in the European Energy Research Alliance, Chris is leading the sub-program on prosumer engagement through digitalization and ICT. So thank you very much for being here, Chris. Now, our last guest is Mr. Stefan Roby, whose bio is missing? No, it's right here. There we go. Sorry, Steffen. No. So yes, the digital transformation of the building sector, it must contribute to a significant increase in resource, energy, and cost efficiency. So that's the main aim for Dr. Stefan Roby, and he is the co-founder of the Innovation Lab at Digital Find It Stats, which is a platform for digital innovations in the construction and real estate industry. He's also responsible for digital building technologies as business manager and senior engineer at the Austrian Institute of Technology. His first experiences in shaping an innovative business model that achieves rapid market growth with sustainable technologies was at the German startup and now internationally renowned company Cloud and Heat Technology. So once again, thank you, gentlemen, for being here today. I do appreciate your time, and I look forward to hearing what you have to say about our opening questions, and then specifically about your own case studies to hear more about your work, so I can pass that along to the cities in our network and to the people listening at home and at the office. So first question, and this is the wide open one, but what is a green building? Who would like to tackle that at the beginning? Martin, maybe that's one for you. Would you like to tell us what a green building is?
Yeah, of course, as you said, a green building might be very different, might cover very different concepts and aspects, as you can derive from all these different labels that exist, and all of them focus a bit on different things. But currently, I would say green building definitely should emit only few carbon emissions, but at the same time should not harm actually the environment on other dimensions. You know, we should not forget that next to the carbon issue, there is also other environmental harms that might occur, and especially along with the material choices, there is still a lot to optimize as well. By saying that, not only the lifetime or the operational time of the building should be considered, but also the whole lifetime. So the optimizing only on one phase is actually not really a good way to go. And at the end of the day, a green building still should also serve actually its main purpose for building to be there, to be used, to people are comfortable, they work there. So the green part should actually follow the main function and not vice versa.
Yeah. Maybe, yeah, from my side, I think it was quite okay what was said already. So it's about reducing emissions, having minimal emissions, and that relates partly, of course, to how the building is constructed and what kind of materials are used, and also what happens with the building when it reaches its end of life and must be dismantled, and how can these materials be reused for constructing new buildings. So that's an important aspect. But of course, it also relates to the energy that the building needs and consumes during its lifetime. Yeah, and there it's clear that the energy efficiency of buildings must be good. Yeah, so they must consume little kilowatt hours for heating and cooling. But I think there's more than the energy efficiency of buildings. It's also important that the buildings uses energy in a smart manner and uses, let's say, energy when the carbon intensity, say when the emissions that come with it are minimal. And that's where I think electrification and the active control of demand response can play an important role to also contribute to green buildings emissions reductions by using energy from a cleaner source and by consuming energy when the source is as clean as possible. So also that I think is important in respect to what is a green building. As a last point, maybe I think also that it's important that a green building behaves well in relation to the grid, because especially if we go to do more electrification, you run the risk that new problems are introduced. And therefore, for a green building to really, say, give a good contribution, it also must have some level of what you could call grid awareness, to make sure that it takes into account that it consumes at times when it's good for the grid, and not causing new problems, for instance.
Very good. Okay, that's an interesting. I hope we come back to that, because that grid awareness and the role of houses within the larger energy sphere is a really interesting one. Steffen, was there anything you'd like to add into that?
Yeah, maybe just interesting remark of Chris, I think, because he's taking the perspective from the single building itself, going to more systemic view, and that's quite interesting. Maybe we can discuss it later. But one thing I'd like to add is I think what makes a green building. I mean, it's part of the definition, but so far we've only been talking about efficiency and energy demand and so on. But what about the environment for the users? I think if we call something green, it should be consistent with a very high quality of living, a high quality of usage. Maybe the tenants, maybe people living using buildings. I think the thermal comfort, but the comfort of usage, the indoor air quality, everything that contributes to a healthy and comfortable environment, I think should really be also part of something we call green, and maybe green building, or as Chris mentioned now, a green energy or green city.
Yeah. So again, where Chris is talking about a house as part of a larger energy sphere, you're looking at the house as a part of sort of a larger part of people's lives as well. So to be green, you have to be healthy, which presumably then also applies to its location. So you've got active transport options, for example, and things like that. Is this okay? Next question is about one of the difficulties that cities often face when they want to mandate higher building standards. So a net zero type building is the property developers, who often throw up quite significant roadblocks. What do any of you have some insight into how to get those developers on side, how to address their concerns? Because in my experience, they'll generally say, oh, this will cost too much and it'll take twice as long, and people don't want it anyway. Chris, go ahead.
Yeah, I'll start this time. So I think indeed that the main obstacles probably are, as you just said, financial obstacles. Yeah. So what's the investment cost? What's the expected payback time of extra costs, and also what's the risk? Yeah. So I think what's needed there is powerful support tools that help them to define kind of an optimal mix of measures that combine, of course, energy efficiency, but also combine that with optimal dimension of local generation, of storage, and also optimal control aspects of buildings, so that they can achieve the net zero targets with a minimal investment and the shortest possible payback time, but also with the least amount of risk. Because it is sometimes very hard to really predict what the payoff for a certain investment will be. And if there would be someone who addresses this risk issue, I think that already could give quite some help. Examples of this are, for instance, energy performance contracts, where ESCOs can give performance guarantees. Also, construction companies probably could in future give such guarantees and not just construct the building, but also assume some longer time responsibility over the building's performance over its entire lifetime.
Okay. Yeah. But yeah, okay, that's an interesting point. Martin or Stefan, would you like to jump in there?
Yeah. Go ahead.
Yeah, I think cost definitely is one of the biggest issues. But what I also hear in a lot of conversations, developers tell me that they have actually piloted things, that they have been monitoring costs, but really what is an hindrance, what is quite an issue is also the complexity. I mean, one thing, if the technology and or even the complexity of communication is too high to communicate the benefits to handle the technical system, then the developer will do it once but not again. So two things. I mean, we have to solve the costs. That's the cost issue. That's the first thing, and means like contractual agreements, like Chris said, are part of the solution. But what we also really try to do is to find better ways of information, to better communicate. How does it work? How is the impact? What is the impact of a green building? What does it mean technically to you? What is your benefit as a developer? I mean, people always ask, why me? Yeah, what is my benefit? That's the first question. And then we have to be really clear in what is my benefit in terms of, well, economical benefit, but also in terms of the quality of building, the environment certificates. I mean, there's a lot of issues, a lot of criteria that need to be discussed and that are relevant. It's not only cost. And we always try to make sure that the developer or the building owner gets the full picture of what is your benefit first, and then how can I achieve it? What is the way? How is the way to get there?
Okay.
So
it's about starting that conversation with, we want to help you build a better house, rather than starting with, you know, a more expensive house that the cost of which can be mitigated. It's about this is what we want to achieve in terms of a better quality product.
I think even going one step further, I mean, before we tell someone what we want to achieve, we have to tell someone what is the benefit for the person to build a green building. I mean, if the developer doesn't know why he should build a green building, he will not be interested in how can I build it, right?
Right.
So
okay.
And it's not only a cost issue.
Yeah. Martin, did you have anything to add in to that?
Yeah, I'd like to. So I was, you know, we are asking the property developers to construct or to renovate in green buildings. So at the same time, the city might ask themselves, what can they provide to the owners in order to make that happen? And I was noting 3 or 4 points down, and one of them is, of course, is if you have like a broader focus, as mentioned before, going away from the boundary condition of the building itself to a larger context of the neighborhood or even of the energy system, then the city might actually provide green energy as an important pillar of buildings to get green, both in terms of electricity, but also in terms of thermal energy, where often, as we realized, only a grid-based solution, depending on the context and depending on the source, is actually really feasible to a building to become green. So to really, the city provides or makes a contribution as well, expands the boundary condition, and that would already help a lot. Secondly, what we have seen in cities, of course, another goodie that the city could provide instead of course, money funding, which is always in short, is actually to adjust a bit the building code in the city and to provide some goodies, either to construct higher or to construct more densely, as a bargain against buildings or neighborhoods getting more green. So if the developers commit to a certain target, they get a certain goodie, and of course that should be still in line with any urban design principles, but still to use a bit this degree of freedom, and because allowing for one story more is such a benefit for the developers that it pays off actually any additional costs, and it does not cost the city a lot. It just changes a bit the appearance of the city, and of course you should make sure that the architectural solution is then still convincing.
Okay, that's really, so yeah, as much of a carrot as a stick approach, some incentives.
Yeah, exactly.
I'm glad you touched on waste heat, because that was one question that's already come in from someone watching the webinar, which is that is the heat recovery from industrial processes, is that part of the catalog of possibilities for a green deal, for a green building?
I mean, I would say yes and no, in the sense of no, if we need to think that the industrial sector, the industrial processes also needs to be decarbonized, and using the internal the energy better internally, doing so-called pinch analysis, where you actually implement different heat pumps and chiller processes that manage each other. There you would reduce a lot internal waste heat. If there's still remaining waste heat in some processes, and there will be, then of course this heat should be used. Similarly to what I said before, the ambient heat, heat from lakes, heat from incineration station, heat from sewage plants, and heat from industries, they need actually then or even data centers, by the way, they need a thermal network in order to bring this heat into to the buildings. And there I see a really important role of cities for coordination and together with their utilities to make that happen. And it's it's quite a challenge to do it, to plan it, to invest. But if you go in city centers, in densely built neighborhoods, it's almost a prerequisite because decentralized solutions are not possible everywhere. You don't have the sources.
Right. Yeah, one I know Dublin has recently launched their first district heat network based off a data centers, which is where they get their heat for that, which is really interesting because that's of course a country that has no history of district heating at all. It's something quite new, whereas sort of Denmark and more in the Eastern European countries a much stronger history of existing shared heat infrastructure, which is great to build on. We're going to move on to the next question, if that's all right. And again, this is quite an open one. But what do you three gentlemen think should be the top 1 or 2 or 3 priorities for a city looking to massively green itself in the coming, hopefully, decade? Steffen, you want to start because you haven't started one question yet?
Yeah, sorry for that. By the way, I have some technical issues here. My laptop is breaking down now and then. So sorry if I'm off. Then it's not because I don't like the discussions, but we have just exchanged the laptop. So I hope it works. Can you hear me well?
Yeah, absolutely, absolutely.
Okay, great. So yeah, I mean, what can the city do is basically what we have been discussing so far. It starts with the reducing the primary energy demand. But as I said, also for me, a very important topic is everything about a healthy environment and the microclimate. But living here in Vienna, which is the most livable city worldwide, as they call themselves, and also one of the greenest cities in the world. Yeah, yeah. I can say that Vienna is really putting emphasis on the following things. I mean, one is public transport. There's really a high urgency on making usage of a really high share of public transport. I think we have about 3/3 of people here in Vienna use public transport every day. Secondly, the district heating we have been talking about. You have been talking about it already. Vienna has a share of about 30% of district heating, and there is a big strategic. I can say there's a big strategy and a strategic urge to green the district heating. So the idea is to have district heating areas where people have to connect. If they are in that area, they have to connect to the district heating. If not, an alternative solution is cheaper and has less CO2 emissions. So and the district heating, of course, you can use a whole range of technologies for greening the district heating. It starts with waste heat incineration with biomass plants, but also with big industrial and high temperature heat pumps, which we are piloting here in Vienna, and AIT is part of that project. You can use geothermal heat, and you can also, as we already discussed, use waste heat of industries. May it be from like in Copenhagen or elsewhere in Sweden, may be from waste heat from data centers, waste heat from industrial processes. It really depends what is available. The city of Vienna is really trying to set up a so-called energy networks, which is where we have a balanced situation between a heat source and a heat sink. So we have waste. They try to settle industry. They try to settle data centers in an area of domestic living. So where the waste heat can be used for heating of buildings and real estate buildings and offices. So this, as I said, public transport, district heating, but also what the city of Vienna has very successfully been doing in the past decades is to keep up a very high share of community buildings. So that means I think we own about, or the city owns about. The city owns about. Oh, hang on, sorry. The city owns about 1/4, 25 to 30% of the buildings, and that gives them the ability. That gives them the ability to really change them in the direction they want. And at the moment, their refurbishment is very much connected to greening the building. It starts with greening the facade, yeah, so introducing plants for improving the microclimate. But we have a big program here for using renewable energies to provide heat via heat pumps and ground source geothermal energy, and also doing appropriate insulation of the building. So I mean, there's a big discussion, of course, about renovation wave. How can we make it possible? But the legislative issue is a regulatory issue, is a really big thing. And of course, in Vienna, it's partially solved by just having holding a big share of community buildings. Yeah. I'd say these are the three big issues, at least in Vienna, that are very successfully used in the past.
Wow, wow! I have to say that's an incredible proportion of public ownership. I can see how that makes a lot possible. It reminds me of the city of Heidelberg, which set out to build the largest passive house district. It was the largest in the world. It's now the largest in Europe after one was emulated in China. But the only way they could do that, it's good. The only way they could do that was because they owned the land. They couldn't mandate developers to build to that highest specification. But as they bought the land to then become the developers themselves, they could mandate. So yeah, maybe the secret is for cities to just buy up everything, all the land and all the buildings in their cities. Might have a budget problem with that, but I tell you what, Chris, can I ask you if you have any comments on that question about the 1, 2, or 3 priorities for cities looking to massively green themselves?
Yeah, very briefly, I think, yeah, just that, of course, if they own a lot of buildings, they have kind of a lot of control about what happens. And I think it's important there to raise their awareness that they should look at smart combinations of course, minimizing the energy demand of the building on the one hand, but also combine that again with the electrification and local generation and storage, because I believe a smart combination of these measures may make it possible to achieve higher emission reduction targets with lower investments. And as already said, of course, there's always a shortage of money here. So you must see how with a limited amount of money you can achieve the highest possible energy reductions. The nice thing when you focus more on this electrification is also that over time, without additional investments, emissions will continue to drop just because the carbon intensity of electricity drops. So electricity becomes greener year after year, and this means that without any, say, additional money, you might kind of halve your emissions in 10, 20 years, which is, I think, a nice add-on feature of that.
Yeah, a long tail of
long-term vision, right? Yeah, yes, indeed, yeah.
Okay, we're running on with time, so I'm gonna wrap that up for the question period, and we're going to move on to the individual case studies that I'm really looking forward to seeing. Martin, we're going to start with you, and then Chris, and then Steffen will go to you to finish off before we go to open up questions from the audience. So Martin, I'll hand it over to you with thanks.
Yeah, thank you very much. Actually, the answer to your question would have been they should do municipal energy planning at its best, and that's a bit the topic I would like to address here in my presentation. And so the question is, do you see it already, or?
Yeah, I see it there.
Okay. Yeah, so I think it's important that comprehensive planning is being done, and there's a lot of coordination actually needed in a city to make this restructuring of the city possible in order to get them green and low or even free carbon. And that's a bit what we were working on since about 10-12 years, since my company actually was founded, starting with the city of Zurich, and we were constantly expanding that also on the international scale. And that's why I'm so happy to talk about this in front of an international audience, actually, because some of the principles and the approaches, they can actually be transferred in other countries, even though the local context might be different and need to be taken into account, of course. I was thinking, yeah, what is actually the challenge? And you know, the more I'm into that topic, I realized that we have, of course, the physical and the technical side on the one hand side. On the left hand side, we have talked a lot just in the discussion before, but there is also the political, the economic, the institutional side of the issue that needs to be considered as well. And these two levels, if you like, they need to be coordinated and get along. And like a forward-looking systemic approach is actually needed, and the different aspects and not only energy and carbon needs to be integrated actually. And without getting the people, the institutions on board, it might be very difficult to implement even convincing physical or technical solutions. That's a bit our approach. We are trying to connect these two things together. If I go to the next slide, so typically, starting in Zurich, but also in other cities, who do you need to bring to the table? Of course, if you have an urban energy planner, it's already good because then you have a certain institutional backup already. If not, it might be worthwhile to think of creating such a position. But on the left-hand side, it's it's the urban planner, it's the Department of Construction, it's the Department of construction permit, it's the energy utilities, and I think that's very important to think of. The energy utility that might provide 98% of gas in some countries. How can you bring them on the table that they see the decarbonization not as a threat but rather as an opportunity? You might have other utilities like wastewater, waste incineration. Sometimes they are city-owned, sometimes they're external, but they need to be part of the discussion, part of the solution, as well as the environmental department. They need to foster and to emphasize different environmental aspects, including actually the health of the citizens, the local climate. You mentioned it for Vienna, to make also the comfort outside of the buildings actually good. And if you have all that on the institutional side, then on the political side, you need the voters, the residents. You have mentioned it, Adrian, because they are finally electing also the mayor, and only if you can convince them, provide benefits to them, you can implement actually advanced policies that are needed actually to restructure the buildings and the cities, I should say. So here just an example that's of the city of Zurich, how the process actually was then structured. So the message here is not that you grasp all the details, but the message is that you need like a structured approach. You need to have the specialists that meet maybe more frequently. You need to have the generalists, as we call them here, that in their everyday life they have other tasks, but still the urban planner, if you can interact with the urban planner and make him aware that energy and urban planning might be either conflicting or even beneficial, then this would also foster developments that help actually to make the buildings at cities more green. And at more high level, the rhythm of changing things, of approving things is, you don't need to back up every little decision, but at some point you need to back up strategic decisions. You need to back up goals on the political level, including the mayor or even the voters. And this organization has proved to be quite effective in the case of Zurich. It might be in details quite different in other cities, of course, but the principle is actually to have a structure to bring the different stakeholders of different departments together, because the silos are not designed to make cities green. The silos, the administrative silos, are designed for all the purposes, but you need to you don't need necessarily to break up silos, but you need to make silos working together, I would say. Then what I call the municipal energy planning, I think again, what is needed is then to a structured approach. You need distinct products in the end, you know, that they are really tangible. In this example, it could come out with a planning map, a planning report, and really measures. That's on the planning side of the medal, and on the right hand side, of course, you need then the implementation. You need the information. You need the involvement of the public. And concrete measures actually that really make a change is needed in such a process. And this framework I'm showing here on this slide was being developed in Switzerland and applied in many municipalities and cities, and has proved that you know, this actually helps to organize cities around this topic I was mentioning before. And with a you know, clear product, clear methodology, the discussion between the different stakeholders is actually eased, because they can then discuss concrete things. Now, if we go to the, you know, a bit more down to earth issue, I would say the challenge is you have the demand of the buildings on the one hand side, you have the potentials of renewable energies on the other hand side, you have limitation, you have local availabilities, you have distances, you have a certain dynamics also on the demand side. You have population growth, or maybe even shrinking, but rather growth in cities. You have some retrofit activities or not, and all these issues, they need to actually be brought together. And the specific challenge in cities is they need to be brought together on a spatial perspective. A spatial match is needed, and that's why we developed a tool and approach I will just show in a minute. So the approach, typically you have to structure these challenges. You know, first of all, you need to know where you are. You know, where is your mission, or is your energy consumption, where is your emissions, what is your building stock. Then secondly, and quite early, you need to set a goal, and sometimes you need to have some fundamentals to define the goal. So the goal might be readjusted, but having a goal is very important in an early stage. Goal can be readjusted later on. Then thirdly, you need a systemic and integral assessment of the demand, of the potentials, and also of costs and benefits, of value creation, of policy issues. So the third part, that's a really you know, demanding piece of work, but it's I think it's important that you do it. And based on this, you can then decide on strategic approaches, maybe even reassessing the goals that you have defined in step 2. Then fifth, it's about implementation, and also there you need tools, data, and the framework to support implementation, and actually also to monitor as a sixth step. And if in the monitoring phase you realize the goals you're not really on track, you need to readjust either the goal or the approach or the measures. So in that sense, it's like a cyclic and not a linear way of doing things. I don't know how I'm in time actually, but for you know, to foster all this, we have developed a so-called toolbox that consists of different models, and actually these models or the machine that you see on the below of the chart should also, of course, should actually serve a purpose. So with this toolbox, you can do the things that are on the top of the slide. So the emission balance, for instance, to define goals and strategies, also to identify neighborhoods where thermal network is feasible or meaningful. It's even about load shaping, grid design. If you think on the impact of what happens on buildings on the grid and on the electricity supply, for instance. I think due to time, I cannot go really into these details here, but I'm happy to answer any questions later on, or you can read some references. We have described these elements.
Great. Thanks very much, Martin.
Yeah, and the remainder of the slides would have been some case studies that I could share, or maybe the slides are shared afterwards. I don't know.
Yeah, I'm sure we can send those out afterwards. Thank you very much, Martin. I know I have a couple of questions for you afterwards, but for the time being, we're going to go to Chris, who's going to share his case study with us. Chris, please go ahead.
Okay, thank you, Adrian. I think my screen is shared now, is that correct?
That's great.
Okay, so let's start then. Yeah, it was said already, I think, to reduce the building emissions, the first thing that comes to mind is to reduce energy consumption of buildings. And it's therefore also, of course, no surprise that energy efficiency is very high on the agenda. But I think it's also clear that the challenge is enormous. If you think about the fact that about 35% of the European buildings are over 50 years old, almost 75% of them is labeled as energy inefficient. Demolition and construction rates are low. It's only about 1% per year. And also the renovation rates are needed to meet these targets. And also these renovation rates are currently too low. It's about 0.4 and I think 1% per year, depending on the country. There was a study from the BPIE that to reach the 2050 targets, we need an annual rate of deep energy renovations of about 3% per year. But currently we only achieve like 0.15% or 20 times less. Yeah. So it's clear that the challenge is enormous. The problem is the deep energy renovations that really have a significant impact on the building's energy consumption and emissions encounter a number of important barriers that actually explains, I think, this too low renovation pace at the moment. So first problem is that these renovations require, of course, a large investment, and this is a problem if the money cannot be found. But even if the money can be found, then you often see that the overall payback time that is achieved with the energy cost savings is very long. Yeah? Typically, this would be like 40 years, or it can be much more. It can be to over 100 years. Yeah? And for many people, this is simply too long for them to consider a deep renovation to be, let's say, a good investment for them. Secondly, there's also the uncertainty and the lack of trust about whether the projected savings can be reached. Yeah? And with that, of course, the fear that the payback time will even be longer than I think what is initially anticipated. And thirdly, such renovations are very complex and many decisions must be taken. There are many options, and people just do not feel comfortable to do that by their own. The second and third barrier are addressed by the energy performance contracting, where ESCOs, energy service companies, they can kind of unburden the client by proposing for them an optimal set of measures. And with that, they also can give performance guarantees for the savings that will be achieved and for the payback time that is resulting from that. Yeah? And they even can take up, if needed, the upfront financing. But for the service, they of course typically take a share of the energy cost savings during an agreed duration, and only after that, the client really fully benefits from the energy cost savings. So although this EPC practice is solving some of the problems, it's not addressing at all the barriers related to the high investment that's needed and the long payback times, which also explains probably why this traditional EPC practice is mainly targeting public buildings, where this apparently is seen as less of a concern. But to address the barriers that are specifically related to the large investments and the long payback times, we are developing something that we call the active building EPC concept and methodology in the Ambience project that started 1 year ago. So what I'm talking about here is still work in progress. The key idea behind it is that reducing consumption is actually not a goal on its own, but that reducing consumption is a means to reach the real goal. Yeah? And the real goal is to reduce emissions. And yeah, as already also talked about in the questions before, emissions can be reduced not only by reducing consumption through increasing energy efficiency, but reductions can also be reduced by electrifying heating and electrifying domestic hot water generation, which, by the way, roughly account for 75 to 80% of the average European household energy consumption. So it's quite a lot. Just to give a figure to illustrate that, an emission reduction of 85%, of course, you can achieve by reducing the consumption by 85%. But you could also reach the same level of emission reduction by reducing consumption by only 40% and achieving the additional 45% by means of electrification. Electrification can reduce emissions because the carbon intensity, that is the amount of CO2 emissions per kilowatt hour of 1 kilowatt hour produced heat of a heat pump, in most cases is much lower than when that same kilowatt hour heat is produced in a traditional manner with gas. As an example, the carbon intensity of 1 kilowatt heat produced in a traditional manner with gas would be about 200 grams. Producing this same kilowatt hour heat with a heat pump would have a carbon intensity of only 120 grams, 40% less, more or less. If we assume an average heat pump efficiency of about 250% and using a conservative estimate of an average European carbon intensity of electricity, which is in the meantime well below 200 grams per kilowatt hour electric. Now, using this all in the active building EPC concept, we therefore promote an increased focus on electrification, and we propose an optimal combination of electrification with building envelope measures that increase efficiency. And we do this to either achieve the highest emission reduction for a given investment budget and expected payback time, or to achieve a given emission reduction target with the lowest investment budget and the shortest payback time. And we also need to keep in mind here that with electrification, we not only decarbonize the heating of the building, but we also decarbonize hot water generation, where envelope measures, of course, mainly address the heating decarbonization. With electrification comes also an important opportunity of demand response active control that can be used to further reduce consumptions by shifting consumptions to times when the carbon intensity is lowest or the energy cost is lowest, or preferably both, which can further improve the results. Or with demand response, it can also generate an income cash flow by offering services to grid or market stakeholders, yeah, which also can, again, in a positive manner, reduce the payback time. By explicitly addressing the investment and the payback time barriers this way, we as well make it appropriate for residential buildings, we think, and this could hopefully also boost the renovation rates to the levels that are needed. And as I said, these levels at the moment are way too low. Besides, these demands response active control opens up the opportunity to apply the concept also to clusters of buildings like neighborhoods or energy communities, where more demand response value can be created by aggregating flexibility and giving this way access to, let's say, higher value streams. And as an additional, say, indirect effect, of course, through electrification and demand response activations, we can all have an additional impact of supporting the integration of more renewables and supporting the grid. The active building EPC performance concept methodology follows largely the same three phases that can be seen in a traditional EPC concept. So there is a pre-contracting phase where a quick scan and high-level potential business case analysis is done. And for the active building EPC concept, specific checks are introduced to explore the presence of flexibility and the willingness to electrify and allow demand response active control. If from the pre-contracting phase we see that there is a potential business case, this is further analyzed in detail in the contracting phase. And in this phase, multiple design options for multiple scenarios are explored in order to find the optimal set of measures and to quantify also the corresponding business case, including all, say, relevant financial and economic KPIs that come with it. For this active building EPC concept in this phase, it is important to being able to model the available flexibility of the building and thereby to estimate the impact of demand response active control. And this is, as I said, important because the energy cost and emissions are impacted also by the capability to shift the electrified consumption to times when the emissions or the costs are the lowest, or where incentives can be earned by offering services to grid market stakeholders. And this must be done in such a manner that these estimates, these performance estimates, are linked to agreed scenarios for which then also performance guarantees can be given, which is important to reduce the risk. If after successful contracting phase an active building energy performance contract is signed, we enter the operational phase that starts with the deployment of all the agreed measures. Then the performance of the building, of course, is monitored and the demand response active control is applied. And at agreed times, like in the traditional EPC, the operational performance is compared against the performance that was guaranteed based on the agreed scenario. To support this contracting phase, we are developing the active building energy performance modeling tool, Abeym for short. And the main component of this tool is the energy cost cash flow calculation component that is able to estimate the energy consumption profile, and from that the emission profile and energy cost profile for a given building design. This is a specific set of proposed measures and a given scenario. And as I already said, these estimated profiles are impacted, of course, by the demand response active control decisions that are taken. The estimated energy cost profiles then serve as input for the financial and economic calculation component that uses the CAPEX and OPEX information and other relevant information to calculate the relevant economic and financial KPIs that go with the proposed design. By using this tool, it's possible to explore multiple design options and explore multiple scenarios, and this way propose the most appropriate design option along with the performance guarantees that can be given for that options, again linked to an agreed scenario.
That's great. Chris, I'm just going to ask you to wrap up quickly if you can,
okay.
so we can move on.
I'll speed up a bit. So I'll not go into more details about the exact functioning of this tool then. Maybe very briefly, a short quantitative example is that to reach a certain emission reduction by 40% at the left side, you can do that by reducing your consumption by 40%. You could also achieve the same reduction by electrifying and using some data available on the efficiency of heat pumps and carbon intensity, where it's also shown here that if over time the carbon intensity, let's say, decreases and let's say is halves, you can achieve a much higher reduction of the emissions. Of course, with electrification, usually the OPEX cost increases. So that's one of the balances that must be made. What's the reduced investment in CAPEX? What's the increased cost of OPEX? And what's then the sweet spot? So what's the best combination of measures? Including also adding local generation and demand response active control is necessary to really create a positive business case where, again, you get this best balance between investments in building envelope measures and in electrification measures combined with active control. And finally, a number of takeaways is, basically see them on this slide, right? So we really think we must not look at just reducing consumption, but also electrifying consumption and making it smarter. And I think all the rest I more or less already said before. Yeah. Apologies for the time overrun.
That's all right. That's all right. It's a really compelling thing, and I think certainly for homeowners such as myself who are looking to do this, it's an exciting thing, and I look forward to seeing the conclusions of the project. Steffen, sure. If I can ask you to take us away with our last presentation of the day, please.
Okay, just give me a second. Okay, now you should be able to see my screen, right?
Yep.
Can you, Adrian, can you see? Me?
I can indeed.
Perfect. Yeah. Okay. Yeah, our solution, I think Martin already said it, talked about this whole thing of evidence-based moderation of stakeholders, bringing everyone together to improve the communication and the flow of information with the project. And I already mentioned that we see this as a very crucial aspect for convincing developers to build green buildings. And why is this important? You know that 80% of the cost of a building is happening during operation, right? Only 20% is planning and construction. But the impact or the setup of these 80% is defined in the really early strategic planning phase. So when everyone gets together and designs the strategy and the draft of the building, in that moment, we define 80% of the total cost of the building. If we don't do it right in the first phase, in the initial phases, every change of track will be increasingly costly. So the later we change our ideas and our concepts, the more it costs, or the less possible it will be. That's why we always try to enable developers to do better informed decisions, to increase the cost of information getting, to bring everyone together, breaking up silos, and at the end, hopefully it results in better quality of buildings and greener buildings. So what we did is, one example is we try to give developers a tool with which they can use very little information, and usually they're not experts in their field, they're not technical experts, they're not architects, but they always talk with architects and talk with technical people, but they themselves don't have a clue what it means, and so they have to rely on what the architect tells them, what the building physicist tells them, what the technology guys tells them. And if they tell them district heating is the way to go, they say, okay, what does it cost? And I go. And if then a heat pump guy comes along and says, oh, you have to use heat pump, that's the future, electrification of the system, that's the only way to go, they say, I don't have a clue, I do it or not. So it's really important, and that's what I mean with high cost of information. It's for the developers and the decision takers. It's very important to justify the information they get, and that's why we try to use, or to like this, for example. I showed here in an example to give a tool which enables them to do better decisions. We can set up a new project. I apologize, it's in German because we have the German standards and building codes in the background, so we only have it in German. But if you want to set up a new project here, we can easily create a new project, give some basic set some basic data like the project name. We call it future-based because that's the building we're sitting in here now. I'm at AIT in Vienna. It's in Austria. Vienna at the Giefengasse 4. It's a building that went into operation last year, and it's an office building. So then we import either any photo that we have. Now we have a Google Maps. We have a Google Maps photo here, or you have an architectural draft. It really depends on what is available. We are using Google Maps now. So we set this up. Then we just at the scale. So we know this is 10 meters here. We get the information by Google. Otherwise, you get it by the architect. And then we can already start to design the shape of the building. It's very simple. We can just follow the outside shape and say these are the 4 outside walls. Then we give some basic information like height of each floor. In this case, it's 4 meters. It's an unconditioned floor area, And then for each single wall, we can say what is the share of window, the share of our glassing. Does it have a balcony or not? Is it connected to ambient, or is there any building that is leading again, or that is connected with it? In our case, it's not. So the share of windows and also the window height. These are the few data that are needed just to set up the architectural draft. And then if we have more than one floor, we can just duplicate. Them. In our case, we have 5 floors. So, and we can, if we want, yeah, for the last floor, we have to say it's the last floor, and it's against ambient in our way, and we have a green roof, and that's it. Of course, every floor can be set up differently, but now we download this model, we can share it, discuss it with architects, send it to our developer, but that stays basically it. So very simple, hopefully only takes 5 minutes to set up a building. Then the developer can import it, gets sent this model by the architect or whoever. We import it and start the calculation. In our calculation, you see we have imported the model now with very brief project infos, and now we can change the building standard. We can say is it actively cooled or not. We can change the temperatures for the demand temperatures for heating and cooling, and we can also set up different technologies. I apologize again, this is in German, but we have gas boilers, we have district heating, we have different kinds of heat pumps, and we also have a block-powered CHP. So the standard technologies are included, and the developer can change, or you can sit together with the architects, with the technicians, and really exchange ideas. You can change the outside shape if you want. If you have good information, you can use the correct U values and G values. Otherwise, we have implemented the latest building codes of Germany and Austria. So depending on the location, if you're in Berlin, Hanover, or Vienna, like we are, the relevant building code is imported, and the values are set up here. And also you can choose different kinds of shading. We have implemented outside shading, inside shading, no shading, and some shading foil. So there are different options for shading. And of course you can change the condition of your roof and basement. So you see very few data. In the background there's always data from the building code. So if the developer has some information, he can add it. If not, we have some standards included. And then you can choose between a simulation of really this building that is just set up, or a comparative analysis. Comparison could be, for example, an increase of the glassing area, the glassing share of the facades. Could be the different shading options, or could also be the construction of the walls or the heating technologies. So we have different options of variant calculations, and basically all you need to do is then start the simulation, and the simulation will be running then. What is happening here in the background? We have a dynamic thermal simulation, so it's not an Excel sheet in the background that is immediately giving us results, but we really have scientific tools connected to our building code databases, and that do for every hour of the year we simulate this building now that you have already seen, including usage profiles, including shading effects, including solar intake, and so on. So really dynamic simulation in a high timely resolution, and it takes about a minute or two, and then we get the results. And you see here, this is the building that we have just set up. Some data about the location, about the cross floor area, and so on. And then we have all the information about the energy demand for heating and cooling, and about the loads for heating and cooling. So you can discuss, the developer can discuss, okay, how much is the energy consumption, and how much does it cost me, because I know the kilowatt price of a district heating system or a heat pump. And then I can really go into closer discussion. I have some proper information based on really good scientific tools. Also, I can go into the whole discussion about comfort, thermal comfort. You see here the different floors. You see the temperatures. So the building developer can go into the discussion of
Stefan, I've lost audio from you.
And that's basically it. Also, as I mentioned, there is the opportunity to really do variant calculations, as we see here. Of course, if we change the window area, the window area has a big impact on the energy demand for cooling, but has almost no impact on the energy demand for heating. So we get a lot of good results and information based on very few data, and we think this is really crucial in really getting one step forward and convincing developers, or helping, it's not convincing, it's but helping developers and decision takers to take better decisions, take more informed decisions, and to speed up the conversation between the architects, the owners, and the technicians, to really bring these different perspectives and aspects together with very few information, with really short time. So that I think is very important, because okay, you can always do a big study, and big calculation takes weeks and costs a lot of money, but we think information must be quick and easy to access, and that's the idea, and we hope we are able to support this with our tools and services.
Wonderful. Thanks very much, Stefan. That was super interesting. We're gonna wrap up this webinar in the next few minutes. I'm gonna ask one of you one question to each of you, if you don't mind. Stefan, we have one question from the audience for your presentation. It says, from the Google picture, we see that there are 2 high-capacity condensers, or is it heat collectors only? From the
oh, it's also condensers. We have here in this building, we have a heat pump system. We have photovoltaics. We have a concrete core activation that is used also for cooling in the summer. Yeah, that's it. We also have a big electrical storage that we use for research services. It's not it's not super innovative, but it's quite okay.
It doesn't have to be new, it has to be effective. Martin, one question for you on your work with cities. Does the model that you showed, does that vary depending on the city size? If you're dealing with a capital city like Zurich or Lyon or Amsterdam, compared to say a much smaller a Nyon or a Vevey down the lake from you in Zurich, does it vary much?
I mean, it varies maybe more across countries. Currently, of course, data availability is always an issue, and we have developed a methodology that allows us for using data that is more or less publicly available on a national scale, if possible. Of course, if in larger cities you might have more data, so you can go more into the details. Also, the issues are more, let's say, sophisticated. So I would rather say the approach is adjusted, but the tool is maybe quite similar, but you wouldn't use all the options and the features of the tool. For instance, in Belgium, we have discovered what we have done for the Leuven city as a case study could be done by any other city in Belgium using just the same data sources. So once we have developed and set it up for a country, we can actually roll it out in other cities or in many cities in the countries. But I would say the most interesting cities are the medium-sized cities. Vienna, Paris, and all these capital cities. They have their solutions, their specific things. They don't need so much of support because they're already quite advanced in all these developments and planning. But the medium-sized cities of 100, 200,000 inhabitants, for instance, I think they are still urban and they have that issue, that challenge. I try to explain, and they are lacking of know-how and people and competences and approaches. And I see the target cities in there, actually, the medium-sized cities.
Yeah, and that matches up with my anecdotal experience dealing with cities. Yeah, certainly, yeah, the Amsterdams and Parises can take care of themselves. They have that expertise in-house. Chris, one question I wanted to ask you, you spoke about taking a neighborhood approach to aggregating flexibility, specifically on the demand side. Does that, when you talk about that, are you talking about just the sum of its parts of a number of houses with electric water heaters and whatnot, or is there also a potential there to add in new technologies like a small grid-sized battery on a neighborhood scale? Is that what you're talking about?
It's both, actually. I think what's mainly important is that you establish a real coordination between the buildings in such a neighborhood or a cluster of buildings. And we think that we need something that goes beyond traditional demand response, in combination with, let's say, storage, but that you can use the flexibility that is available in these individual buildings more effectively if they, say, communicate to each other what they intend to do, maybe as part of some optimization that they did, and also communicate what they maybe could do, what type of flexibility they have, of course, within their comfort boundaries, which are very important. Mm-hmm. And by such, say, more active information sharing, I think you can probably often say maybe avoid the need to having to install, let's say, grid level batteries and stuff like that. Right. If you have a number of buildings causing problems, I mean, other buildings maybe can shift their consumption to absorb the problem, and then, say, not needing the investment of a grid level battery, because typically, batteries, they're nice, but if you look at their investment cost and payback time, it's not that positive yet. Yeah, and we really think we need something there that goes beyond demand response. Demand response is really very, actually reactive buildings causing problems. Of course, they all at the same time react to the same signal, and by smarter information exchange, and that's what we mean with this grid-aware buildings. I think in the US they talk now a lot about the grid interactive buildings. If you really establish an active communication, I think much more can be achieved.
Great. Okay, well, I think we're gonna leave it there for today, gentlemen. I wanted to thank you for your contribution. That was a really interesting chat. The webinar was recorded, so it'll be available for distribution from the European Heat Pump Association. If there's nothing else, I will thank you for your time, and of course, thank the people at home and office who have followed us along for the last hour. All right, have a lovely day.